Hello and welcome to Learn IT Courses Online. We're very glad that you're able to join us today as we continue on this journey on Introduction to Database Administration. We did mention that at the core of it is all the data, the table that we have, or the tables that we have, and how we use SQL to interact with it. We need a proper database design, security to make sure that it's secure and protected, and only people have access to what they should have access to, not more, not less. Today we're going to be talking about something that's very core. Almost any database administrator, one of the top questions is going to come in any interview that you have or any position that you're working. One of the biggest challenges is usually performance. And that's what we're going to be talking about today. When we have that much data, great amounts of data, millions and hundreds of millions, if not even billions, spread through amongst different tables, and we're trying to query that information or load information, it becomes very slow, and that affects the business. It affects their website. It affects their ETL processes, and it creates a lot of problems for any business. And that's why performance tuning is very critical for the survival of any company and database. The first thing that we want to talk about is, again, usually when people talk about performance, it's about SQL and how to optimize the SQL. But in this introductory course, we'd like to kind of introduce the overall concept. If we know the concepts, that's more important than just being able to optimize that SQL statement. So what we need to realize and understand is first identifying performance bottlenecks. There's different pieces where things could be slow, because a lot of times someone could come to you as a database administrator and say, the database is slow, a very generic, general statement. And now we have to pinpoint where the problem is. So when we hear that statement, we're going to be able to identify where the problem is, knowing all the factors involved in that database processing or manipulation. And as such, this is why we need to understand this overall picture. And this is actually off a product called Spotlight. That's a Dell software. It's one of many tools that we could use. And we're going to look at different tools to be able to have that overall picture. On the very left side, we have the sessions. That's you or me trying to log it into a website. We're getting into that server. And next, we have a connection to our SQL process. Now it's our insert statement or select statement that's querying that system or website to get that information. And then we go into the SQL memory. Now we're into the server level, and where they have that kind of buffer cache, an area of temporary memory where we can query. And the first time through, we make it all the way down to storage. And that is where the data files are, the data files for the database, whether it's a C drive or the D drive and so on. And that is where we'll pull that information, we bring it back. Part of it gets dumped on the SQL memory, the buffer cache, and then through that process back again, the SQL process. And it gives this back to us in the website or the Windows application that we have, or if it's a bank, I'm on the ATM machine. So this is kind of the life cycle of how we go and grab that data and come back with it. In some cases, databases have become more modernized, which means the next time that I log in within a given certain time period, I will get that session, I'll go to my SQL process, I'll go to my buffer cache, and sometimes that data is still stored there. So I don't have to go all the way to the storage and deal with I/O issues, input, output into the actual server level, but I could deal with that memory that I have and pull it back through my SQL process and back to my session where I get my data back. So now we have a very overall idea of where all the different pieces are. The next thing is there's a variety of tools to identify those issues. Like I said, this is Spotlight, and we're going to talk about different other products, third-party products, as well as SQL Server itself that has powerful tools that allows us to kind of drill down to see where the issue is. Because even though I'm a database administrator and I really don't care about the kind of the firewall, the internet level, or the server level, I may not be necessarily the primary person in there, but when I have an overall picture, it's very important for me to be able to pinpoint and actually work with the other teams and help them in identifying what the root cause is of performance. The next thing then is performance tuning and optimization. Now that I know where is there something that's slow, more than likely for me as a database administrator, it's the SQL statement or the insert statement or the update statement, the SQL statement that's being executed against my database. Why don't we use the word fix the performance problem? Why do we use the word tuning or optimization? The reason we do that is because under no circumstance can I click on a website to do a search against the database and for it to go from the session level to the SQL to the memory and all the way to storage and grab that information and come back in 0 seconds. We always expect certain milliseconds on the session level until I create a connection through the SQL process, a few more milliseconds, and then through my memory, and then a few milliseconds, to say the least, and then to my storage. And depending on how much data that I'm grabbing back, whether it's just one record or a million records, and then in which case it could be seconds or minutes or even hours if it's one of those annual reports, and then back memory, SQL process, back to my session again. So the reason we don't start fixing is because we don't fix it. The data grows, it's relative, and there's also time needed. No matter how minimal it is in milliseconds or seconds or minutes or hours, there's time needed from the session level to the storage and from the storage back to the session level. And that is why we tune it. We make sure that it runs as fast as possible within that capacity. If I have a highway that's where the speed limit is 70 miles an hour, then I expect to drive at 70 miles an hour. I want to make sure my car goes up to 70 miles an hour, but it can't go any faster than that, and it shouldn't go slower than the minimum speed limit. And that's what we're doing, is we have a certain tunnel that we're going through, so we can't go any faster than what tunnel that tunnel allows us to, but we want to make sure that we tune it to make sure that it runs at the maximum speed allowed by that tunnel, or we optimize it, and that's why we use those terms. So for us as database administrators, as we will learn, there are three attitudes that we need to have when we're fixing that SQL, when we're optimizing our queries and processes in our databases. The first one is reactive, and a lot of people do that, and that's not good. That is where we sit at our desk and someone comes up and says the database is slow, or this SQL statement is very, very slow. How do I resolve that? Well, being reactive, then it's when we're being told that, we're encountering that, and we go in and fix that SQL statement, which is what happens a lot of the time. But then there's something that we could do that's a little bit better, and that is us being involved and being active. And by that I mean is there's certain areas in the database where we can look and see SQL statements that run regularly. And based on that inventory of the SQL statements, we do what's called a benchmark, which means that this SQL statement of logging into the website and just querying your account information should run within 3 seconds on average. So every user that logs in and runs it, it runs within 3 seconds. And then we have a weekly report that runs within 3 minutes. And then we have an annual report that runs within 3 hours. And so when it runs within 3 seconds, and the weekly within 3 minutes, and the annual within 3 hours, as long as that's my average, that's my benchmark, then that's fine. But before I'm being told something is running slow, then I could put in my measures to make sure that the report that's running 3 seconds doesn't run over 10 seconds, for instance. I could place my benchmark, which basically says the weekly one that runs in 3 minutes should not run more than 10 minutes. And then I raise my red flag before anybody comes to me and lets me know about it. And similarly with the annual report that runs in 3 hours, if it's running more than 5 or 6 hours, then I want to notify myself and deal with it before I'm being notified. Finally comes what's called proactive performance. And that is where I can monitor things before they break. I can have an idea of where my top processes are and my top SQL statements are. And so I could deal with that and remedy that before it becomes an issue that's evident to other people. And those are the kind of things we're going to talk about in this session. So I really hope you enjoy this. It's very exciting. And like I said, performance is something that's very important for us as database administrators. So hope you enjoy this session. So as we mentioned earlier, there's two issues that I would have with performance. There's the case where I know there's a specific query, select statement, or SQL statement that has a performance issue that's taken a long time to get the data back, and I'd like to analyze it and find the best way to optimize it. Or there's the overall performance issue that I'd like to kind of pinpoint where's the issue. Is it with my IO? Is it with my SQL statements? Or some other reason? So before we tackle this directly, let's go ahead and look at an overall picture. So on SQL Server, I could go to the server, do a right click, and then go into Reports, Standard Reports. And then from here, I can actually have an idea of the general performance issues, things that might be slowing down my database and my database components, and deal with them before they become a high priority. Maybe they already are, but I'd like to kind of pinpoint them a little bit more. So if I'm looking at top queries by every CPU time, or top queries by average IO time, or top queries by total IO, whatever it is, let's go ahead and pick on this one for now. I can click on it, and it then runs back and gives me a list of those statements. So here I do have a general idea of what my top 10 statements are that are affecting my performance. Here's the actual statements. And long before someone comes and complains about this insert statement and how much time it's consuming, I can proactively go in and optimize that process and see what needs to be done to make it run faster. Long before someone comes and says, I have a problem with this select statement, I can go in now and kind of analyze it a little bit more and get more information on it and see how I can optimize it, because it gives me the top 10 SQL statements. So this is one of the ways that we can go in and do that. Of course, usually the database administrator is not primarily responsible for the server, but one thing that we could do is also do a right click on the server and activity monitor, which gives a high level overlook on the different resources in my server. And I can refresh it at different intervals, a second, 5 seconds, 3 seconds, and then look at the different processes that I have, the IO and so on. So this is another way of proactively looking at other sources or other forms of bottlenecks before just tackling directly the SQL statement. So this is how I'm trying to be proactive. Those are the kind of things that I would look at, and I can set up notification depending on what tool that I'm using so that I get alerted once we go beyond that benchmark line. When it comes to a specific select statement or a SQL statement, there's a couple of things that you usually want to look at, and that's kind of the standard. And that is, before executing a select statement such as this that runs against a table with over 1 million records on it, I want to have an idea if this is running optimal. Am I using an index? Is it the best performance? So usually I want to have an idea of how SQL Server's brains are thinking. How is it going to execute? How is it planning to execute my statement? So to find the plan of how it's going to execute it, we do a right click and we have what's called the execution plan. So that's one way of doing it, where I can click on this on the statement before running it to see, am I going to do a full table scan or am I going to use an index in that case? So again, I want to make sure that I'm using an index so I get my report faster. In this case, it's saying that it's going to be a table scan, as we can see that statement. So probably that's not the best way to run it, and I probably need to create an index. So the fastest way to find that out is by right click and then looking at the estimated execution plan. Well, in this case, it seems kind of evident, since my condition is on the customer name where I need to create my index or should create my index. But in some cases, we have multiple tables that we're querying and multiple conditional statements, that it's a little bit more challenging. And even if it's just one other way to kind of confirm our theory is using another tool in addition to the execution plan display, is to right click and analyze our query in Database Engine Tuning Advisor. Analyze our query in the Database Engine Tuning Advisor. It's going to pull that tool and put our SQL statement in there. And it's already set. It already knows the SQL statement. All we have to do is just run it. It runs for a little bit and then shows us the result of what the recommendations are. And as we can see in this, that is suggesting that we create an index, and the estimated improvement is going to be 99% in terms of performance. So this is not only just showing us what we need to do, but telling us how much time we will save or how much of an improvement that would be by creating this index. Well, okay, Database Engine Tuning Advisor, you sold me on the idea that I need to create an index. How do I get that script? I just click on the definition of the script, and it gave me the statement of creating a clustered index, a generic name on this table, and the entire statement that I need. So yes, I can kind of rename the index with something fancier or run the script as is, but not only does the Tuning Advisor recommend or give me a recommendation, but it also gives me the SQL statement that I need to run to fix that issue as well. So it's a very great tool. It's an amazing tool with performance tuning. Last but not least is a very powerful tool for performance tuning and also for analyzing our performance, called the SQL Server Profiler. A lot of times we might be monitoring during hours. So if I work 8 to 5 I'm right there in front of the database, an issue happens, and I'm able to capture it. But sometimes there's a process that runs at a later time. In cases like these, SQL Profiler is a very powerful tool, in addition to the time that I'm actually working, because I can start by creating a trace, and I can trace certain things. I can call my trace whatever that I like, and then choose the template that I'm looking. What am I tracing? What am I tracking in there? So use the template of my choice. Run it, and it's going to monitor all the different transactions that are running in my database, down to the level that I've identified, whether it's all or specific items of SQL or store procedures and so on, and I can stop it. So this comes in handy if I want to trace something specific or something general, whether I'm in the office or I'm out of the office. SQL Profiler is a very powerful tool in monitoring that information so I can later track it down for performance. So we said earlier, we need to identify our performance bottlenecks. Some might not be within the realm of the DBA, but it's important to know them. If there's problems with I/O, if there's problems on the server level or connection level, it's nice to be able to identify it and help other teams with it. So we've got tools such as SQL Profiler or third-party tools, or the activity monitor that allows us to see the server level, the connection level, along with the database level itself. So identifying the performance bottleneck is very important. Being able to use tools that are within SQL Server or even third-party tools is very important for a database administrator. And then being able to tune performance and optimize performance. It's not something that's fixed because, again, the size of the tables varies and the performance and the I/O within one server to the other changes, even if it's the same number of records. So what we're looking for is not a fix in performance. It's always tuning and optimizing based on the circumstances that we have. Performance tuning, again, we could be reactive and wait until something is slow to go in and fix it, in which case if it's a SQL statement, we can optimize it by creating an index or maybe creating a hint or adding a hint to the SQL statement. We could be active by benchmarking, and of course we could be proactive by proactively monitoring the different tools that we have that will show us our top SQL, even if it's under the benchmark, and deal with them before they become an issue and go beyond the benchmark ideal time. Best of luck with all of your endeavors, and thank you for joining us again at Learn IT Courses Online.